sticking with binary representation, we are going to have a look at negative numbers. Is that recording? Fantastic. Okay, so we're going to stick with what we learned before in terms of an 8-bit register. I'm going to go 1, 2, 4, 8, count with me, 16, 32, 64, 1, 2, 8. Okay? But we've got a negative number. I want to represent a negative number. Okay? For example, let me try and represent minus 33. Okay? That's what I want to try and represent. Now, with this, we can't represent negative numbers at this moment in time because these are all positive numbers. So what we need to do is turn the 8-bit register into a 7-bit register. Okay? So this is going to be our focal point here. And all we do with this one is we give that, so this is called 2's complement for some reason, 2's complement. We turn that into a negative 128. Okay? A negative. And that's going to be our starting point. So we put a 1 in there. Okay? The binary 1 in there. But we've got to get to minus 33. Okay? So thinking about the negative and positive number line, negatives, positives, we're going to still be somewhere, if we say this is negative, this point here, this end point, negative 1, 2, 8, we're going to be, if that's, so for example, that's going to be our negative halfway between that and that, negative 64. Halfway between that is going to be negative 32. Yeah, and then so on, and then incremental, yeah, bop, bop, so on and so forth. So we're going to go towards, we're heading towards the 0. Okay, so we're going to add, remember these are all positives, we're going to add these onto our negative 128. Yeah? So negative 128 plus positive 64 would give us what?
Negative 64.
Negative 64. So I put 1 in there, and now I'm on, here, I'm on negative 64. Now, if I go and add that, positive 32, onto negative 64, what do I get?
Negative 32.
Negative 32. But I want to get negative 33.
Yeah.
So I don't want to be doing that. Yeah. Okay? But, in theory, and based on what we've learned in the other one, I should really be able to just put 1s in here, but we'll work it out. So if I add 16 to this, positive 16, plus 16, I should get 48, negative 48. Yeah? Then I add an 8,
40.
Yeah? Plus 8, negative 40. Plus 4,
36.
Negative 36. Plus 2.
34. And then 33.
Yeah. Plus 2. Plus 1. Negative 33. So that is my 2's complement. We'll make a little note of that. 2's complement with an I. Representation.
But how do we find a negative number from binary representation?
If we've got a binary number,
yeah.
Well, you've got to know that it's going to be a binary number, because generally speaking, if this wasn't flagged here as a negative number, then you would just take these numbers here, whatever it is, and add the 128 onto it. So we'd have 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1. So we'd have a number that looks very different to that. So we've got to know that we're using 2's complement and that the 1 under the minus 128 is a flag to identify it as being a negative number.
So if you were told to, if you were just given a binary number, just given no 2's complement, no nothing, it means it's going to be a positive number.
Generally speaking, it's going to be a positive number, unless it's stated.
Unless it's stated.
Yeah. So shall we do another one?
Sure.
Okay. And then we'll maybe work backwards. Okay, so I'll let you do one. Is that useful?
Yeah.
I think it is, isn't it? Yeah. So negative 100. Negative 100. Now then, one thing to point out, this is 7-bit register. So if we think about the 7-bit register, and I will delete them all, I'll just put it underneath for now. What number is that? If I put all ones in there,
255.
7-bit.
Isn't it 255?
Add all these numbers together.
Yeah.
I should get what? Pretend that's positive. Think about what we did before.
Yeah.
If I put all ones in here, what's the next number in the sequence?
128.
100.
Minus 1, 127.
Beautiful. So bear that in mind. The biggest number we can have is either positive or negative, based on whether that's got a 1 or a 0 in it. Positive or negative 127. Okay? So on the timeline, I'll have put that there. The maximum number this way is minus 127. And the positive 127. Okay? So we're doing minus 100. What do you reckon?
First one's going to be 0.
Well, we'll put a 1 in here to start with. Let's change the colour. Yeah, I've put a 1 in there, so we know it's a negative number.
Yeah.
Okay, where do we go? So I'm starting at 128. Okay, I've got to get to negative 100.
Okay. So you don't add 64.
We can't have 64.
You don't add 32.
We don't have 32.
You can add 16.
So we're going to add positive 16, which gives me 112.
Yep.
Okay,
You can add 8.
we can add 8.
Yep.
Plus 8, which is also negative.
Oh, 4.
104. So equals 104. Negative. Add the 4,
Yep. But
which
then
equals plus 4,
Okay.
which equals negative
100.
100.
So that means the other 2 are 0.
The other 2 zeros. Beautiful.
Nice.
Beautiful. Last challenge. Perfect. Let me just rub that out. Come on. Okay. I'm going to give you a number. See if you can convert it into a denary number. Okay. So.
So to convert it to a denary number, first you have to add all of them together. Isn't that right? Or the ones that have a 1 in them.
Starting with 128.
Yeah.
Yeah. It's a negative. It's got. So what is this representation?
So we do not add 64. We do not add 30. We do not add 16, but we add 8. It's going to be negative 120. And then
What number is this?
this is 7, 6, 15.
One less than this.
15.
15.
Yeah.
So all that adds up to 15.
Yeah.
Okay. What do we do?
15 plus negative 128. Okay, yeah.
Equals
113.
113.
Negative 113.
Beautiful. Negative 113. So that's how you do 2's complement representation. That is a flag, a negative flag. So last one, just while we're here, this should be fairly obvious. Why is that rubbing out? Okay, just to finish, what number would this be?
There's gonna be 6. And then 32 plus 64. What's 32 plus 64? 66. 96 plus 6. Which is going to be 1 or 2. Positive.
It's a positive. We don't need to put a positive in, but. Good.
Good.
Happy with that?
Of course.
Yeah?
Yep.
Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.